This lesson is on justifying triangle congruence using the flowchart. So we're going to go ahead and talk about the flowchart. So it's very similar to the last lesson that we did using the flowchart, but we took away the first level. In the last lesson, we had a lot of givens as our first level. And then the second level, we talked about something being congruent to each other right here. And then after that, we had all the justifications right here, which was the definition of congruence. But in this case, we may actually have as different definitions involved. So we're going to make a statement of something being congruent and then explain what is that definition that allows us to make that statement. And eventually right here, it's going to go down to two triangles being congruent to each other. And then we're going to talk about are the four conditions. So one of the four conditions will apply to the definition. So and the definition that we want to add to today's lesson is on the reflexive property, which states that the term is equal to itself, that is the W is equal to W. For example, in the figure, the length of DB in the triangle ADB, so ADB right there, is equal to the length of the side DB in triangle CDB by the reflexive property, so DB is equal to DB. So what happens is there's actually two triangles right here. There's one right there, and then the second one right here. And this leg of both of the triangles are on top of each other, so they're sharing a common leg right there. So that's why we're saying that the DB is equal to DB. Let's look at example 1. So determine if the two triangles are congruent. So I'm going to go ahead and highlight the one triangle right there in our purple. And then there's our second triangle down here in our green. Now technically this right here, the two legs should be on top of each other, so you shouldn't be seeing two separate colors. But I'm putting in two separate colors so you can see that there are two triangles in this figure right here. So like in our last lesson, you want to go through the four conditions that we mentioned about and then kind of plan to see which of the four conditions apply to this triangle right here. So I'm going to go ahead and use this angle right here as my starting point right here. So my first statement I'm going to say is that the angle ABD right there is congruent to angle CBD right there. And it's because of definition of congruence. Because this figure gave us the markings right there already, so we know for a fact that they are congruent to each other right there. Next statement I want to make is that BD, which is the purple line right there, is congruent to BD, which is the green line right there, and because of the reflexive property that they can be congruent to each other. Third statement is that angle ADB is congruent to angle CDB, and it's because both of these guys right here are 90 degrees, so we know that they are congruent because they're the same size. And so this is the definition of congruence. Now I have all three statements, so now I can say that the triangle ABD is congruent to the triangle CBD, and the condition is because of angle, side, angle. As you can see, this is angle right here. The reflexive right here gave us the side, and then this 90 degrees gave us the angle. So that's why it's angle, side, angle right there. Okay, let's look at example 2. So again, same thing. We have two separate triangles on top of each other. So I'm going to go ahead and highlight this one right here in our purple and the second one in our green. And they both share is this baseline right here of AB right here. Going through your four conditions, which one can it be? Well, I can see that there's a marking of an angle 1 right here. So I'm going to go with my angles first. So I'm going to go with my angle ADB right here, which is this angle right here, is congruent to the second triangle of ACB right there, because both of those angles were given to us that they were congruent. Next statement I'm going to make is that the angle ABD right there, so another angle right here, is congruent to the other angle of BAC right there. And it's because both of those have a definition of congruence, so it's given to us that there are two markings on each of those angles, so they're congruent to each other. So then our last statement we're making is AB is congruent to AB because both of these lines are shared. And the reason or the justification is because of reflexive property. So then we can say that triangle ADB is congruent to triangle ACB, and the condition that satisfies this is because of angle, angle, side. And if you remember, the angle, angle, side was that there's an angle, and then you skip, and then there's another angle, and immediately should be a side right there. So that's why it applies angle, angle, side. Our last example, example 3, says determine if two triangles are congruent. So again, we can see there are two triangles involved in here. And again, the purple and the green should be on top of each other right here. They share a same leg right there. But again, we're just trying to show you that there are two triangles involved in here. So the first statement I want to make is that the DC, which is this line segment right here, is congruent to DA right there. And the reason being of definition of congruence because the marking has been given to us. The second one is that AB right there is congruent to CB right here, and the definition of congruence because again those markings have been given to us. Our third one, because we need a third one to help us to figure out which of the four condition it is, and that's going to be our BD is congruent to BD because again these two lines share each other right there, and so that's going to be the definition of reflexive property. So now I have my three statements and three justifications. So now we can then go forward and say that the triangle DCB is congruent to triangle DAB, and the condition is because of side, side, side. As you can see, all of these sides are congruent right there.